description, 2 points in remaining for write up. Okay. So in last lecture we are completed pneumatic load cell. In that only 2 point writing are remaining here. For any constant applied force, the system attain equilibrium at a specific nozzle opening, and a corresponding pressure is indicated by the height of mercury column in a manometer. Full stop and next line. Last sentence. Since the maximum pressure in the system is limited to the air supply pressure, the range of the unit can be extended only by using a large diameter diaphragm. Only by using a large diameter diaphragm. Okay. Here force measurement devices are completed. In force measurement devices, weight and balancing, probing ring, then hydraulic load cell and pneumatic load cell. These 4 instruments are completed under the force measurement devices. Then next point is torque measurement. Next concept is torque measurement. Okay. At the first lecture of this chapter, definition of torque is covered. Here I repeat, it is the product of magnitude of force and perpendicular distance of line of action. Okay. This is the definition of torque. In that our syllabus only 2 points is there: hydraulic dynamometer and eddy current dynamometer. This is the instrument of measurement of torque. Torque is related to the measurement of speed, means revolution per minute. Yeah. Give the heading torque. And write down the definition of torque once again. It is defined as product of the magnitude of force and perpendicular distance of the line of action. Of force from the axis of rotation. From the axis of rotation. Full stop. Then give the heading instrument used in measurement of torque. Instrument used in measurement of torque. In that first, hydraulic dynamometer, and second, eddy current dynamometer. Hydraulic dynamometer and second, eddy current dynamometer. Before before starting of hydraulic dynamometer or eddy current dynamometer, we are going to learn what is mean by dynamometer. Okay, here dynamometer, dynamometer or short form dyno. It is a device to measure torque or rotational speed of engine, prime mover, or motor. Dynamometer means it is a device or instrument to measure the rotational speed of engine, motor, or other rotating prime movers. Okay, dynamometer इसको बोलते हैं. What is mean by dynamometer? It is a device measuring the torque and rotational speed. Rotational speed means revolution per minute of an engine, motor, or other rotating prime movers. Okay, it is called as dynamometer. So it is instantaneous power may be calculated and usually displayed by the dynamometer itself as kilowatt or bhp. Okay, so write down definition of dynamometer. Definition of dynamometer. It is a device. It is a device to measure the torque and rotational speed and rotational speed in bracket rpm of an engine comma motor or other rotating prime mover or other rotating prime mover. Full stop. Okay, these are the concept of dynamometer or definition of dynamometer. Then next, types of dynamometer. Give the heading types of dynamometers. Types of dynamometer. In that, first, eddy current dynamometer. Eddy current dynamometer. Don't write down absorption only, because of all of our absorption, only compound dynamometer is absorption or it is coupled with electric motor dynamometer. So all of our is absorption only. Second, magnetic power brake dynamometer. Magnetic power brake dynamometer. Third, hysteresis brake dynamometer. Hysteresis brake dynamometer. The next, electric motor or generator dynamometer. Electric motor or generator dynamometer. Next, fan brake dynamometer. Fan brake dynamometer. Then hydraulic brake dynamometer. Hydraulic brake dynamometer. then force lubricated, comma, oil shear friction brake dynamometer, oil shear friction brake dynamometer, then water brake dynamometer. And last, compound dynamometer. Compound dynamometer. These are the types of dynamometer that only eddy current dynamometer and hydraulic brake dynamometer in our syllabus. Okay, so focus on only hydraulic brake dynamometer and eddy current dynamometer. Then next title, hydraulic dynamometer or fluid friction dynamometer. Hydraulic dynamometer or fluid friction dynamometer. Hydraulic dynamometer or fluid friction dynamometer. I request all of you to draw this diagram within 5 minutes under the heading hydraulic dynamometer or fluid friction dynamometer. Hydraulic dynamometer or fluid friction dynamometer. I request all of you draw this diagram. See the construction and working of hydraulic dynamometer, is also called as fluid friction dynamometer or water vortex dynamometer. This diagram show the vortices, mean the flowing of electric current with the help of fluid. See the construction. This is stationary casing in that shaft is coupled or attached. This shaft is connected to the rotating disc, and this rotating disc other side connected with the shaft, and this shaft is connected to the engine to measure the output, means torque. Here prime movers means input supply or initial stage. Here input will be given, means current will be passes with the help of this shaft, and this shaft is connected to the rotating disc. This rotating disc rotate with the help of stationary casing, freely moving bearing, frictionless bearing is there, and this rotating disc is other side connected to the shaft, and this shaft is connected to the engine to measure the torque. When initial starting shaft is rotating at high speed, then other side shaft is also rotating the same speed, and then when we apply the braking system to stop this rotating shaft, then you have to measure the how much torque is created with the help of this rotating disc. Okay, so here see the details. The unit consists of essentially two elements. One is rotating disc and second one is a stationary casing. The rotating disc is key to the driving shaft, means left side shaft of the prime mover, means input, and it revolves inside the stationary casing. Okay. Then the casing is mounted on anti-frictional bearing and has a brake arm and a balance system attached to it. Such bearings allow the casing to rotate freely except for the restraint imposed by the brake arm. Okay. Then further the casing is in two havels, one of which is placed on either side of the rotating disc. Semi-elliptical recess in two casing match with the corresponding grooves inside the rotating disc to form chambers through which stream of water flow is maintained. Okay, and then last sentence here. When brake is operating, the water follows a helical path in the chamber. Vortices and eddy currents are set up in the water, and these tends to turn the dynamometer casing in the direction of rotation of the engine shaft. See the here vortices and eddy current are set up in the water, and these tends to turn the dynamometer casing in the direction of rotation of the engine shaft. This tendency is registered by the brake arm balance system that measure the torque. Means vortices and eddy current with the help of water, they turn the dynamometer under the casing with the help of rotation of engine shaft. And when you apply the braking system to balance this rotation, here you have to measure the how much torque is created. Okay, so write down this unit consists of essentially two elements, namely a rotating disc and a stationary casing and a stationary casing. The rotating disc is keyed to the driving shaft of the prime mover, and it revolves inside the stationary casing. Inside the stationary casing. Full stop and next line. The casing is mounted on anti-friction bearings and has a brake arm and a balance system attached to it attached to it. Full stop. Such bearings allow the casing to rotate freely except for the restraint imposed by the brake arm. Imposed by the brake arm. Full stop. Then further, the casing is in two havels, comma, one of which is placed on either side of the rotating disc. Full stop. Semi-elliptical recess in two casing match with the corresponding groove inside the rotating disc to form chambers through which stream of water flow is maintained. Full stop and next sentence. When brake is operating, the water follows helical path in the chamber. The water follow the helical path in the chamber. Full stop. Vortices and eddy currents are set up in the water and these tends to turn the dynamometer casing in the direction of rotation of the engine shaft. In the direction of rotation of the engine shaft. to stop. This tendency is resisted by the brake balance arm, by the brake arm balance system that measure the torque. Okay. This is the overview of hydraulic dynamometer or fluid friction dynamometer. Then next, eddy current dynamometer. Eddy current dynamometer. So draw this diagram within 2-3 minutes. All of you, please draw this diagram under the heading eddy current dynamometer. See the construction and working of eddy current dynamometer. Under the cast iron stator, this is steel rotated. Two-ted steel rotated is placed in that two-side anti-frictional bearing is attached, means rotating shaft. And this side cooling water in and cooling water out. And this steel rotated connected to the exciting coil. When you supplying the current of this exciting coil, this rotating steel rotor absorb this current. This is called as eddy current, and this exciting coil heated. So this anti-frictional bearing is rotated with this stator steel rotor rotated with the help of anti-frictional bearing, and this absorbing current or heat get removed with the help of water. So this water is used as for purpose of cooling the engine. Okay. Here the electrical absorption dynamometer operates on principle that when isolated conductor moves through the magnetic field, voltage is induced in the local current flow the short circular path within the conductor. These currents called as eddy currents get dissipated in the form of heat. Here you have to supply current. This current passes to the existing exciting coil. This coil is attached to the steel rotor, two-ted steel rotor, and this current is called as eddy current. A two-ted steel rotor is mounted onto the shaft of the test engine, and it rotates inside a smooth bore cast iron stator. The clearance between rotor tooth and stator beam are very small. Then the stator carries an exciting coil which is energized with a direct current supplied from external source. Further, the stator is held gently and proactively on anti-frictional tuners and is provided with a brake arm to which a scale pan or spring balance is attached. Okay. Then when the dynamometer is under operation, the rotor turns and it causes a constant change in the flux density at all points of the stator. Consequently, eddy currents are induced in the stator, which oppose the rotation of rotor. The movement of resistance is measured by the brake arm, and so the torque and shaft power can be estimated. Here means dynamometer under in operation with the help of eddy current. This eddy current are opposed to rotation of rotor, means applying the brake system. These movement are resistance is measured with the help of braking system to measure the torque and shaft of the engine. Here, so write down this electrical absorption dynamometer operates on the principle that when an isolated conductor moves through a magnetic field, comma, voltage is induced and local currents flow in a short circular path within the conductor. Full stop. These currents called eddy currents. these currents called eddy currents get dissipated in the form of heat. Get dissipated in the form of heat. Full stop and next line. A toothed steel rotor, a toothed steel rotor is mounted on to the shaft of the test engine and it rotates inside a smooth bored cast iron stator, comma, the clearance between rotor tooth and stator being very small. Full stop and next line. The stator carries an exciting coil which is energized with a direct current supply from an external source. Full stop. Further, the stator is held gently. The stator is held gently and proactively on anti-friction turnons and is provided with a brake arm to which a scale pan or spring balance is attached or spring balance is attached. Full stop and next line. When the dynamometer is under operation, when the dynamometer is under operation, the rotor turns and it causes a constant change in the flux density at all points of the stator. At all points of the stator. Full stop. Consequently, eddy currents are induced in the stator which oppose the rotation of the rotor. Full stop. These movement of resistance is measured by the brake arm and so the torque and shaft power can be estimated. So the torque and shaft power can be estimated. Okay. So today stop here. Place your roll number and leave the meeting. Division A, place your roll number and leave the meeting. Division B, place your roll number and leave the meeting.